We're going to see today how we generate bond graph models for hydraulic systems. On the screen you see a model of the system. You can see it has a couple of tanks in here, a valve and a discharge. Very simple hydraulic system, and I'm going to outline the steps that you should take to model hydraulic systems. So the first step that we're going to say, well, let's call it the steps. Step number one, is recognize the elements. Alright, so you see I have already written in here, and recognize is resistor here, the C element for the tanks, the inertia and the resistance of the pipe here, and this obviously is a source of flow as well. So you could write in here that this is a source of flow in here, and this is an effort source, but not an effort source that puts pressure into the system, but rather this is the atmospheric pressure, which we're going to call it pressure equals 0, so that this is charged to the ambient. So this is we recognize the elements. The next step that we do is we use a one junction to represent the distinct flows. All right, and that we are going to use a sketched dotted version of the system, and my intent is to draw the bond graph on top of it, on top of the system itself, so that you can recognize the elements on a one-to-one correspondence between the bond graph model and the physical system. So maybe it'd be a good idea to change colors here, just for emphasis. And this is the one junction. I'll do a retouch so that one here, we have a one over here too, and those are the distinct flows on the system. So this obviously is a source, as I mentioned before, and we have the other elements above here. So what we need to do is to use a one junction, as we have in here for the distinct flows on the system. Then the next step is going to be to attach the elements that experience those flows. Very good. So in this case, you can say this is a source of flow, which we call it SF, and it has a value Q in there. And then this would be obviously like this, see? The other one over here on the right hand side, this one is a special one, because this is a source of effort. The discharge is going to be by the variable E. In this case, the pressure is going to be equal to 0, but we represent it like this, see? And we need to put a little arrow in here, which is for an activated bond, which in fact says that the flow is free flow in there, but this is not putting any pressure onto the system, but rather is the reference pressure, in this case the atmospheric pressure. The other elements that we need to attach are, of course, this I element in here, this one in here, and then you have this other on this junction we will have the I element, which would be, put the I over here, and we also will put the R element, yeah, or we could draw it towards the bottom so that it is a little bit more you know, it really doesn't matter, but just so that there's more space, and really, so we could just do here, say this is the I element, and then you have in here the R element. Okay, we are done with all the elements with this step that requires to put the elements that experience those flows. Then the next step that we do is to use a zero junction to represent the differences in flows. You know, some elements are going to see the difference, so we have to create those differences. So it's very obvious that on the tank, the flow that goes in here minus the flow that goes in here is what goes inside the tank. So you could say this flow minus this one, this is going to be let's call it like this. I think at this point we need to put numbers. That is Q. This flow I'm going to call it, why don't we call it Q1 then, there, to make it easier to understand. This other one over here we're going to call it Q sub 2, and of course this is going to be Q sub 3. Okay, so just clean this up a little bit, and then we'll continue here. So in here you see the difference between this flow and this one. This, the difference between those two. Is what goes into this tank in here. So this is going to be in here Q2 minus Q sub 3, just like the one that you have in here is Q sub 1 minus Q sub 2. See, very good. So and finally the next step that we have in here is use a you will say attach the elements that experience those flow differences. Okay, so in here we have a we have to attach the C element, obviously. Well, there will be a space in here, hopefully. We put the C over here, and we also put the other C element over here. See? So in doing this and drawing it on the bond on the system itself, I think that you can see a one-to-one correspondence between the elements on the system the different elements on the system and the actual hold on for a second. Yeah, and the actual system itself. So you have in here, you have the right here, you have this flowing here, you have this also right there. The difference between this and what goes in here is what goes into the tank. That is done by the 0 here, and there's the tank, the C element. The I and the R are over here, and this is the one in here for the I and the R. And you have on this side the difference between this and this. So by the way, the R's are important because they make differences and they establish what the differences are. And this is attached to the C element, and you have over here the ambient, the discharge. And this is the bond graph model that you have. Now you could enter this into the CAMG software, and at this point you could say you could say, why don't we write it like you could say in parentheses, you could say you can enter this model in CAMG. It will number the bonds and assign the causal marks. Okay, that is my preferred method, and you could do the simulation from this model. However, you could do several things in here that are you could simply, that are other steps that I don't believe they are totally necessary, but if you want to, you could simplify the bond graph model a little bit, or you could number them specifically if you want to have specific bond number and enter it into CAMG that way. You could simplify the bond graph model so that it doesn't have this ones in here like this, so it doesn't have this, but you have one here, one in here. Just very small things, but that, like I say, you don't really need to do. However, just as a matter of practice or convenience, perhaps you say, to practice the assignment, we could actually do that. But this is something that CAMG is going to do. Now, what we can do, just for, like I said, as a matter of exercise, is to assign the causal marks in here, perhaps with a different color pen, and then we will enter this into CAMG and see what the assignments are. So in here, you if you have the causal mark this way, if you have it like this, then it means that this has to be like this. We assign it so in the C in integral form, or the I in integral form. I like to start with the I's usually, so it really doesn't matter. But if you do this, it makes this like this. And if that is true, you see this has two flows, forces it to be like this. Sets the flow here, and then it will be like this. All right. And then over here you have the this one is in here. You know, I am forgetting this R element in here. Well, to be consistent, let's change the color to the way it should be. So let's erase this one, and then with a red pen put the R element that I'm missing in here, this valve right there, this valve, so this is the R element. Okay, so in here we have it like this. We need to assign this integral form to the C element and then see what happens with the rest. So in here we go, okay, right here, there you go, assign it. That makes this like this, and if that assigns the effort here, the other one has to be like this, and then this one junction will complete like this. So this is something that CAMG would do for you. However, if you want to verify this, we can enter this into the CAMG software, and you will see that the assignments would be exactly as they are here. So it might not be a bad idea for us to, just a matter of exercise, to do that and then go to the CAMG software. So why don't we perhaps reduce it to a simple window here so that I can actually see it like that, and then I will go to the software and enter it there. So if you go over here in whatever, you know, wherever is installed, and then we run it, and we are going to enter that bone graft model into the system. So here you have, I'm going to keep it on the left in here. Maybe we need to make it a little smaller or not. Well, let's do our best. So we go over here and see if the CAMG software wakes up, and I am going to I'm going to run this so that we can enter the bone graft model over. The only thing is I'm having an issue with the mouse here for a moment, and hopefully it's a temporary problem, but now the mouse is back. Okay. Anybody sees where the mouse is? I think we have just a moment. Let me see this mouse. We are going to